We know the perimeter of this trapezoid is 16 units, and the top base is only 2 units long. We also know something unusual. The slanted side is exactly the same length as the bottom base.
And from that, we have to find the exact area?
Yes, it looks like we're missing too much information, but there's a clever way to uncover everything we need. We have a right-angled trapezoid, A, B, C, D. The left side is vertical, so the angles at A and D are both 90 degrees. The top base, AB, is 2 units. The total perimeter is 16 units. And the important clue is that the slanted side, BC, is equal in length to the bottom base, DC.
So those two sides have the same unknown length?
Exactly. Let's call both of them A. And let's call the vertical height, AD, B. Now, use the perimeter. We have 2 plus A plus A plus B equals 16. Combining the two A's gives us 2 plus 2A plus B equals 16. So the height is B equals 14 minus 2A.
But we still have two unknowns.
Right. So now we need one more relationship. This is where the geometry comes in. From the top right corner, B, draw a perpendicular straight down to the bottom base. Let the point where it meets the base be M. Now the trapezoid is split into a rectangle on the left and a right triangle on the right.
That makes the triangle much easier to work with.
Exactly. Since the rectangle's top side is 2 units, its bottom side, DM, is also 2 units. The vertical side, BM, is the same as the trapezoid's height, so BM equals 14 minus 2A. And the entire bottom base, DC, is A. Since DM is 2, the remaining piece, MC, must be A minus 2. Now look at right triangle BMC. Its horizontal leg is A minus 2, its vertical leg is 14 minus 2A, and its hypotenuse is A.
Perfect. Now we can use Pythagoras.
Exactly. So the quantity A minus 2 squared plus the quantity 14 minus 2A squared equals A squared. Let's expand both squares carefully. The first gives us A squared minus 4A plus 4. The second gives us 196 minus 56A plus 4A squared, and the right side is A squared. Combining like terms gives 5A squared minus 60A plus 200 equals A squared. Subtract A squared from both sides. 4A squared minus 60A plus 200 equals 0. Divide everything by 4. A squared minus 15A plus 50 equals 0.
That one should factor nicely.
It does. We need two numbers that multiply to 50 and add to negative 15. Those numbers are negative 10 and negative 5. So, the quantity A minus 10 multiplied by the quantity A minus 5 equals 0. Therefore, A equals 10 or A equals 5.
So which one is actually possible?
Great question. We have to check the geometry. Remember, the height is 14 minus 2A, and a physical length must be positive. So, 14 minus 2A must be greater than 0. That means 2A is less than 14, so A must be less than 7.
Then A equals 10 can't work.
Exactly. It would make the height negative, which is impossible. Therefore, A equals 5. So the bottom base, DC, is 5 units, and the slanted side, BC, is also 5 units. Now, let's find the height. B equals 14 minus 2 times 5. That gives us 14 minus 10, which is 4.
So we have both parallel bases and the height now.
Exactly. The top base is 2, the bottom base is 5, and the height is 4. The area of a trapezoid is 1/2 multiplied by the sum of the parallel bases multiplied by the height. So the area is 1/2 multiplied by the quantity 2 plus 5 multiplied by 4. 2 plus 5 is 7, and 1/2 times 4 is 2. Finally, 7 times 2 equals 14.
So the exact area is 14 square units.
Exactly, 14 square units. And the nice part is that the answer only appears after we use the geometry to eliminate the impossible solution.
A small detail, but it makes all the difference.
Absolutely. If you enjoyed this problem, give the video a like, subscribe for more math challenges, and I'll see you in the next one.